Look around you right now, from the phone in your hand to the car on the street and even the airplane in the sky, materials engineering is behind it all. But what exactly is materials engineering? Simply put, it's the field of science and engineering that focuses on understanding and improving the stuff things are made of, metals, plastics, ceramics, glass, and more, to make products stronger, lighter, safer, and more functional. As one writer cleverly described it, materials science and engineering uses the periodic table as its grocery store and the laws of physics as its cookbook to create new materials. The impact of this field is vast, from shoes, to tooth fillings, to solar panels. Nearly everything in everyday life has been worked on by materials scientists. In this video, we'll explore how materials engineering quietly powers our world by looking at three familiar examples: smartphones, cars, and airplanes. First, let's consider the smartphone in your pocket, a device that materials engineers have helped make incredibly powerful, lightweight, and durable. The glass screen on your phone isn't ordinary glass at all. It's often a special toughened glass, such as Corning's Gorilla Glass, engineered to resist scratches and shattering. This allows your phone's display to survive drops in daily wear. Next, think about your phone's battery. It relies on a lithium-ion cell, which uses lithium, a lightweight metal with a high energy storage capacity, to pack lots of power into a small package. Without advances in battery materials, our phones wouldn't last nearly as long between charges. And of course, at the heart of every smartphone is the microchip, made from silicon, a semiconductor element. In fact, by weight, about a quarter of a smartphone is silicon, enabling the incredible computing power we carry around. Altogether, a modern smartphone contains a remarkable variety of materials. By some estimates, roughly 80% of the stable elements in the periodic table can be found inside it. From the cobalt in the battery to the copper in the wiring and the rare earth elements in the speakers, it's a miniature showcase of materials engineering. Thanks to materials engineers, our phones have bright touchscreens, long-lasting batteries, and speedy processors, all wrapped up in a slim, pocket-friendly design. Next, consider the car you drive every day. In modern car assembly lines, advanced materials come together to build vehicles that are both safer and more efficient than those of the past. High-strength steel is commonly used in a car's chassis and frame to form a sturdy safety cage that protects passengers in a crash. These new steels, engineered at the microscopic level, can absorb immense impact forces, helping your car pass crash tests with flying colors. At the same time, lighter metals like aluminum are used for body panels and engine parts to cut down weight, which improves fuel efficiency. A lighter car needs less energy to move, saving you gas and reducing emissions. In fact, car makers have managed to shed hundreds of pounds from modern vehicles by switching heavy steel parts to aluminum alloys. Some high-performance and luxury cars even incorporate carbon fiber composites, materials that are incredibly strong yet ultralight. For example, carbon fiber reinforced plastics are used in certain sports cars and electric vehicles to give them a strong frame with much less weight than traditional steel. The result of all these material innovations is a car that's light on its feet but tough where it counts. Advanced materials help improve gas mileage, and at the same time they ensure critical areas, like crumple zones and roof pillars, remain rigid and protective in an accident. In short, every time you buckle up and hit the road, you're benefiting from materials engineering. It's the reason today's cars are both safer and more economical than those built decades ago. Finally, let's talk about airplanes. Commercial jets are often called aluminum tubes with wings, but these days there's much more than aluminum involved. Modern aircraft like Boeing's Dreamliner are built from cutting-edge materials, notably, carbon fiber composite materials for much of the fuselage and wings. In fact, composite materials make up about 50% of the primary structure of the Dreamliner, helping to dramatically reduce the plane's weight and improving fuel efficiency by roughly 20% compared to older designs. Lighter weight means the airplane can carry more passengers or fly farther on the same amount of fuel, which is a huge advantage in aviation. That doesn't mean metals have gone away. Engineers still use advanced aluminum alloys in many parts of the plane because aluminum is light and strong. The Dreamliner, for example, is still about 20% aluminum by weight. For extremely critical hot sections, like a jet engine's interior, even more exotic materials come into play. Jet engines face hellish temperatures and forces, so materials like titanium alloys and nickel-based superalloys are used for turbine blades and other engine components. Titanium alloys can retain high strength even at temperatures of 400 to 500 degrees Celsius, making them ideal for the most demanding engine parts, for example, the fan and compressor blades at the front of many engines. Meanwhile, ceramic coatings and heat-resistant superalloys allow the engine's turbines to spin in gas hotter than red-hot lava. All of these innovations, carbon fiber composites, advanced alloys, high-tech ceramics, are products of materials engineering, and they have enabled airplanes to become safer, more reliable, and more efficient over time. Next time you fly, remember that it's the ingenious choice of materials that makes it possible for a 400-ton metal bird to soar through the sky. From our pockets to the skies, materials engineering truly is a hidden hero behind modern technology. It's the reason we have gadgets that fit in our hands, vehicles that save fuel while keeping us safe, and aircraft that can cross oceans on a single tank. And the innovation isn't slowing down. Materials engineers around the world are continually researching new composites, alloys, and polymers to build the future, whether it's smarter electronics, cleaner energy, or even space travel. We hope this overview gave you a new appreciation for the materials that make our everyday life possible. If you enjoyed this exploration of how engineering shapes the world around us, please give this video a like to let us know. Subscribe to Stephen the Engineer for more engaging breakdowns of the science and technology that power our lives. And don't forget to share this video with friends who are curious about the marvels of engineering. Your support helps us keep discovering and explaining the wonders of the engineered world. Thanks for watching, and see you next time.